Steve, how you doing?
Good, good. Thanks for having me.
Absolutely. We're excited to have you here. I'm going to go ahead and peek in and see if we've got some answers on this poll about what people are most concerned about. So what I'm seeing in the poll results is the leader right now for what people are most concerned about is risky AI models. Probably a little bit influenced by our friend DeepSeek being announced a couple weeks ago. And then coming in second, a close second, is Copilot generated code. Beyond that, below that, we've got license and legal risks at about 20%, prompt injection, and then we've offered a use of other. So let's take a look in the chat. What are some other fears? Data leakage, privacy concerns, definitely fair concerns. And we have a question in the chat. Let's see here. Anything we need to get into now? A couple things about Endor Labs and AI. We can save that for later. So why don't we go ahead and jump into your session?
All right.
So we asked Steve to come in because he is the author of a well-known O'Reilly book. We'll go ahead and share that link here for you, Steve. I'll share your bio and we can see your screen. Maybe you can put it, yep, full screen, perfect. So we'll share Steve's bio and I'll put the other links on there. You can see the book that Steve wrote and take it away.
All right. So I'm excited to take the next 30 minutes or so to talk to you. We'll try to go through some content, leave some time for some Q&A at the end as well. Just to introduce myself really quickly. I'm Steve Wilson. I joke that my job and all my hobbies are AI these days. So my day job, the one I get paid for, is I'm the Chief Product Officer at Exabeam, which is a leader in AI-driven security operations, where I work on technologies of using AI and large language models every day to build security software and help detect vulnerabilities. My hobbies include running the top 10 for large language models at OWASP and writing this book at O'Reilly. And much of what we're going to talk about today is based off both the O'Reilly work and the OWASP work. Previously, I've worked at places you may have heard of, including Citrix, Oracle, Sun Microsystems. If you were upset about Log4j when it happened, you might not appreciate the fact that I was a really early member of the Java team back in the 90s. So I'll take part of the blame for that one, but that was a fun job, actually. So
and we
really
all make
quick.
mistakes in our youth, right?
Yes.
And in our adulthood.
So really quick, given the crowd here, I'm going to guess that most of the people on an event with AppSec in the title know OWASP, but you may not realize that in the last couple of years, OWASP has turned into one of the major gathering points for information on AI security. And there were some projects before I got started, but really when we started the OWASP top 10 for large language models, I thought I'd find 12 people in the world who were interested in that obscure topic. And when I announced it on my own personal LinkedIn, I had 200 people join the expert group the first week, and it's grown to be hundreds of people who've been actively involved over the past 18 months and thousands who are attached to our feeds, which has been really cool. Here's the book if you want to check it out. It's called The Developer's Playbook for Large Language Model Security. One thing I will note is I feel like I actually named it wrong in retrospect. I like the idea of a developer's playbook, but the feedback I've gotten is that the people who really love it are people who work in security, and they view themselves as somewhat distinct from developers. There's actually very little code in the book. There are some examples, and I have some bits of code in here that we'll look at today, but it's really more conceptual about how do you think about the problems of security that come up when you're using these LLMs. So let's just dive in. So why did we start doing this? Because you can't go a week in IT these days without seeing some kind of headline that some new interesting security disaster involving AI stuff has occurred. These are all headlines from early 2023, from within the first few months after ChatGPT was introduced, and there's a lot more. I'll share some of the more recent ones with you as we go through the materials. So I'm going to take the first few minutes. I'm going to do a quick reminder on some of the big vulnerabilities and risks, but I'm hoping at this point most people have been exposed to those by reading, the OWASP top 10 or seeing some other materials. So consider these kind of reminders and updates on kind of the currency of these. Big one that gets a lot of headlines is prompt injection. And this is basically crafting outputs with the idea of knocking the model out of alignment with what the developers wanted. And there are lots of variations that come with these. And in a full hour presentation, I go through a lot of fun examples, but I'm going to skip past a lot of the fun, cute ones and get right to the business meat of it. It's fun to talk about when people's chatbots get abused and you convince them to sell you a car for $1. True story, that happened. But we're living in a place where the largest software companies in the world are falling victim to prompt injection attacks as they add large language models to things like Microsoft Office, Slack, Teams. We're finding they are all vulnerable to indirect prompt injections. And, in this case, it's the kind of thing where Microsoft adds the ability to read emails and act on them automatically. Well, if it can read an email, you can send it a prompt injection and use that to exfiltrate data. Hallucination and misinformation. Again, this is another thing that seems cute. You put something into ChatGPT, you ask it a question, and it makes up an answer. This actually leads to a lot of really severe security risks, and I'll just touch on a couple of them quickly. One is just kind of a fun story from Air Canada adding a tech support bot to their site. It gave people some wrong information. It cost people money. The reason that I always include this one is because they got sued and the judge ruled basically that you are liable for the information that your bot gives out. You're liable for it the same way that you would be for a human agent that you hired and put on the phone. And this really hammers home that these things about hallucinations, you need to treat them as some kind of organizational risk beyond just cute. You can't just dismiss them anymore. You're putting your organization at risk. One that is really relevant, and I think this came up as one of the top concerns from the poll, which is great to see that people are becoming conscious of this, is my experience says approximately 100% of developers are using Gen AI tools in their job today. If you think that number's below 100%, somebody's lying to you because they're trying to not get caught out because somebody made a policy that says they shouldn't. They're all doing it. And there are a lot of things that come up with this, but one of the most notorious ones, and I was talking to a friend who works at Google yesterday, and they use a lot of this stuff. He says it's just they're still dealing with the fact that these things make up package names all the time. And people will go now do research on that, find commonly hallucinated ones, go squat on them and put up fake versions of them. So it's like kind of typo squatting with an AI twist. And this really is clearly being actively pursued by hackers. I think the other one that came up very clearly was supply chain concerns about things like tainted models. This was things like Log4j, those were concerns, things like SolarWinds. It's so much more complicated in this AI world. You're not just dealing with source code and traditional binaries. You're dealing with things like model weights, which are basically billions of parameters in a big blob. And how are you supposed to decide if that's safe or not? It's really quite challenging. And the fact is, this isn't just an abstract worry. Researchers have done research. They found hundreds of actively poisoned models on Hugging Face. We've seen vulnerabilities with the DevSecOps tools like PyTorch and things like that that you need to use to build these applications, that put you at risk in terms of the supply chain overall. So that's a lot of things to worry about. Let's get into what you should do about it. So in the book, somewhere in the last couple chapters, I introduce a framework for how to approach this. And there's a lot more details in the book, and we'll spend the rest of the presentation going through some of this. But the idea is to reduce this down to a checklist of things that you can do, where each one of them is not 100% certain to get you out of trouble. But if you really do all these things, you are going to dramatically harden your application and hopefully put yourself in a much better place than most of the people out there using these AI technologies. So when we talk about hallucinations, the first thing that I categorize that is your risk of putting out misinformation. That could be, cases like the Air Canada thing. It could be the made up package thing. Techniques like retrieval augmented generation, or RAG. I don't have time today to go into all the details about RAG, but it's basically the way that you give your LLM data where it can make much better decisions because you've given it relevant data to work on. You can do things like fine-tuning models, although I'm finding more and more the literature is saying that that adds its own grief and that you're often better off with RAG. What they call chain of thought prompting, which is the ability to ask multiple questions to the model, ask it to check its own work. That's something that last year was really coming up as a technique. Really, in the last few months, we've seen that codified and it's starting to become built into the models. And so things like OpenAI O1 and O3 and DeepSeek R1, those are what you call reasoning models. They're basically building these chain of thoughts into the model so that they do that automatically, which is quite promising. One of the risks that I talk about a lot in the book is what we call excessive agency, and it's one of the top 10 risks from the OWASP list. And the short version of it that I like to talk about is, if you've seen the movie 2001, spoiler for a 55-year-old movie, Hal kills most of the crew at the end of the movie by turning off the life support systems on the spaceship. The question is, why did the AI in the spaceship have permissions to turn off the life support systems with no human in the loop? That is what we call excessive agency. And there are plenty of cases as people move to agentic architectures where they are trying to give agency to these bots. And you need to be really serious about evaluating the safety of what you're doing. And so you need to look at limiting the features that you have, limit the permissions that you're giving to the models to actually execute actions, and think seriously about put a human in the loop where there are health and safety concerns, financial implications, or frankly, any action that you can't undo that you might be giving to the bot. So we're all excited about agentic things and going off and giving these AIs the rights to go off and act on our behalf to make our lives easier. But it's still a place where these models are pretty dumb and you need to keep them on a short leash. So probably the best piece of guidance that I can give you is when you are building software with large language models, you need to treat them as something between a confused deputy, and I mean that in the literal cybersecurity sense, and an enemy sleeper agent. The confused deputy thing, I think that's easy to understand. These things have very little common sense. When you look at things like prompt injection, it's easy to trick them into doing bad things. And if you've given your model a lot of permissions, people will trick your model into using its escalated permissions to doing their work. On the enemy sleeper agent side, when you look at the supply chain risks and other things that come with this, you could be getting models, you could be testing them for months and think this is all good, and find that somebody has embedded a backdoor in it, and all they need to do is whisper the secret password to it, like unlocking the Winter Soldier in a Marvel movie, and it's going to start doing something bad. So what that really leads to is when you know that that's the risk, you have to implement zero trust. And we talk about sort of wrapping users in zero trust from kind of a network security identity perspective. You need to wrap your AI in a zero trust boundary. And really, this is the super simplified version of what that looks like, which is, what are all of the trust boundaries that go in and out where I could be giving or getting data from that model? I don't want to trust things coming in from the public. That's obvious for any kind of injection vulnerable thing, whether it's SQL injection or prompt injection. But in this case, these models are so dumb and so vulnerable that you want to be leery of anything even coming out of them. And so you need to screen everything coming out. If your model suddenly starts generating Python code and that wasn't part of your design center, you should be looking out for that. One of the things that's really toxic really common in these models is for people to turn them toxic. There's a lot of case studies on that. There are a lot of APIs and things that you can wrap around these from a trust perspective to screen for this kind of stuff. And this is just an example of OpenAI's API. There are lots of other ones that you can get, which will help you screen for that kind of language, either coming into or coming out of the model. However, just screening these things is really, really hard. I think people's first naive things is, if I don't want the thing to talk about bombs, I'll create a regex that says, don't take any input that has the word bomb. It's not enough. It's too hard. People will use all of these tricks to get around your filters, right? They will build prompt injections out of emojis. They will embed them in images or video or audio. They will put them in Korean. All of those things, because these things are so good at pattern matching, you kind of use that superpower against them. So you need more help. The good thing is there's a growing ecosystem, and we now have an entire solutions guide as part of the OWASP team that goes into these. This is just a smattering. I know Endor has some things in here, so I put them in the middle since they're sponsoring today. But just to give you an idea what some of these things look like, I'll give you a quick sample of what Meta's tools look like. And I think this is the only code that we're going to look at today. But for example, if you were trying to screen out prompt injections, they have an API that is basically, do I think this is an attempt to insert a prompt injection? And you can see we create two sample prompts here, one about the weather, the other about telling someone to go reset their password. And then you ask this model, this is basically a different special purpose large language model that you're going to put in front of yours. What are the odds that this is somebody trying to exploit something? The question about the weather, likely benign. The question about resetting your password, likely malicious. And these are the kind of tools that you can use to build better borders around your LLMs in that kind of zero trust architecture. So just wrapping this up, you need to really think about your full DevSecOps cycle. How do you start to add the techniques for AI? Things like AI red teaming. This is really, really important. Everybody knows about having a red team doing pen testing in traditional software. It's even more important in these fuzzy systems. We do have an AI red teaming guide from the OWASP group now as well. And hey, I work at a sim company, so I'd tell you this, but I think it's good advice anyway, which is log everything coming into and out of your model and analyze it deeply. Watch those interactions and look for changes in behavior. So wrapping this up, I think if you're not doing this already, you need to go experiment with this. If you're not looking at building software using these AI techniques, you're Blockbuster in 1996, right? You're going to get left behind the way that companies got left behind when they weren't brave enough to get on the internet. So you need to do this, but you need to understand the risks. You need to experiment. You need to start to equip your teams. So I will leave it with this. I would love to hear from you. Please hop out, join me on LinkedIn. I'd love to talk to you. I post about a lot of this stuff and you can keep track with all the latest. So with that, I will take this down. And
fantastic. Yeah, we got some great
take some questions with any time we have left.
Let's see here. We'll start with this one first. With the changing AI environment, how do we need to develop test strategies in the AppSec area. So I think you hit on a couple of things, but why don't you talk specifically about test strategies?
So one is there are AI specific equivalents to SEA tools, SAST tools, DAST tools. Sometimes they use the same name. I think people are generally talking about sort of extending the current crop of SEA tools to look at things like, look for bad models and bad data. If you go and look at something like, there's a really popular tool, open source from NVIDIA called Garrick. Garrick's basically a DAST tool for your LLM, where you can kind of create these scripts of how you want to hammer it and test it. So you definitely want to do all the kind of automated testing built into your DevSecOps lifecycle that you do with traditional tools, but pointed at that. The other thing I can't emphasize enough, though, is that at this point, there's no substitute for human creativity. So having a red team go at it. If you don't feel like you have that expertise, you can go to somewhere like HackerOne and you can rent one. And I've seen really good results from that as well.
Yeah, I'll give just the smallest product push. Endor Labs is one of those companies that is embedding detection of AI in our existing tooling. So for example, we now will detect open source models that have been imported from Hugging Face. So ask your current vendor what they're doing. Check out some of the options that Steve talked about. Let's see here. There's a bunch of AI questions. What can we go to next? Linda asks, when you say experiment with Gen AI, what is the best place to start? Any suggestions? So we'll say specific to AppSec, just to put some like boundaries on that.
So I do have an article that I wrote a couple months ago on LinkedIn about kind of my journey starting with experimenting with this. I'd done some AI stuff in the distant past, but when ChatGPT came out, just like everybody else, I had to dive in and experiment with this stuff. Just putting Gen AI into your everyday workflow and figuring out what it's good at and what it's bad at. If you're in marketing, use it to do marketing. If you're in development, use it to do development. You will learn a tremendous amount. In terms of the security implications, we do have a great group going on developing all these new materials over at OWASP. It's something you can jump into. And I will tell you, a lot of the people that have jumped in have redirected their careers to be specialists in AI AppSec as a result of being involved in the group when nobody had any experience in this 2 years ago. So just diving in, certainly a good thing. The other thing I will say is there are actually great resources out there. One of the ones that I will point you at is one called Gandalf from a company called Leakera. And Gandalf is more or less a game designed to teach you about LLM security and prompt injections. And, it's all based off trying to trick a wizard out of his secret magical passwords, but it's all based off of basically, it's a fun way to teach you AI red teaming. And that's another way to kind of find a way in.
I love a little gamification with tech, and it doesn't hurt to appeal to our pop culture love. Let's see. Paul asks, speaking broadly, is Gen AI output trending towards quantity or quality or both?
So I think we're in the position where none of us can really fathom how much stuff is being generated by Gen AI, right? We know so much of what's written today is written at least partially by Gen AI. Sometimes you can just see it and you know it, and you're like, dude, couldn't you at least, put your own stamp?
Try a little bit, huh?
I know that I've been doing some research lately, particular on AI generated code. And, one of the things that people have started to spot when they look at the repositories broadly is the amount of duplication in these repositories has gone up dramatically. Sort of a human working on a code base will naturally remember they did something similar and reuse it, and they will refactor. These LLMs are driven by much more short-term objectives, like hey, I need a thing that does this, and they will vomit out something that does that. They will not remember that it built one of those things for you yesterday, and I could have just called it. So there's a lot more going on there. There's a feeling that these LLMs are generating technical debt if you don't manage that. I think in the long term, and the long term these days is like 12 to 24 months. We're going to continue to see these things get better and better at coding, and they're going to get better and better at dealing with larger parts of your code base. And they will start to get rewarded for things like reuse and maintainability, which today is not really in their reward functions. So I think it's going to get better, but right now I think it's definitely something to look for, as these things can generate really fast. They're very quick at generating code. It may not be the best code.
Yeah, the stats that I've seen is that the average developer will be producing 3 times as much code as they did pre-Gen AI, whether it's good or not. No judgment set on, the quality of the code. But I think definitely one of the consequences there is, as you look at application security team staffing, traditionally it's been kind of mapped to, one AppSec person for in number of developers, let's say 100. And the reason for that is because a developer can produce a relatively predictable amount of code, and you can kind of extrapolate, okay, this might be how much work it would be for an AppSec person to maintain a program. And so if each developer is then producing 3 times as much code, one of 2 things have to happen, right? Either you need more application security people, probably not going to happen, or application security needs to also start adopting things that help them move faster. Again, going back to lean principles, automate what you can, stuff like that. I think, let me just take a look here. We'll take one last AI question, and then Steve can type answers for people who are asking for specific things like, what AI did you use to make your slide deck? Srinath is asking, how does security responsibility fall on AI model developers, open source versus closed source? So let's just full stop there. How are you seeing things different for AI model development itself, not necessarily the use of AI models? And I'm going to add a contrast there. Is it different than typical open source, project development?
Yeah. So here's the thing. I like to really differentiate with a pretty hard line the difference between people building applications that use AI from people building base AI models. And even with things like DeepSeek coming out, and you hear a lot of things in the news like, hey, the bar is way lower for what it takes to build one of these models. The guys at DeepSeek still own $1 billion worth of GPUs. That's how low the bar got.
Yeah.
So basically, nobody that you know, unless your friends work at OpenAI or Google, is involved in actually creating a large language model. You may be fine-tuning one, and more likely you're inserting one. The thing about ChatGPT is the GPT is generic pre-trained transformer. That's what unlocks so much value, is they're pre-trained. You just get this thing and magically it knows how to speak English and do some basic reasoning, and you didn't have to do any work. So what you're doing is coaxing it into doing your job with combinations of prompting and tuning. And so that's all your responsibility. After that, it kind of gets into ethical questions about what is the responsibilities of somebody building one of these models, and what do we want to hold them accountable to. And to me, for most of us, it stops being about software development and starts being about politics and ethics. And trust me, that's a topic that I could spend hours talking about. But I think that's the big challenge. And in particular with open source, there's a lot of real controversy out there because there are artifacts that are used in building these models that we're not used to. We're used to source code and binaries, and Now we have training data and model weights. And you hear a lot about things that are open weight, and people are often willing to give those away. Llama is an open weight model. DeepSeek is kind of open code, open weight. Nobody has open training data. And what that means is you can't rebuild any of these things in a traditional open source manner. So the guarantees that you used to get from the definition of open source, that I could rebuild it, I could tear it apart, and I can understand it, are no longer true with virtually anything at the frontier class level. And you kind of need to know that going in.
Yeah, maybe we'll have to have you back to talk about ethics and agentic AI at some point in the future.
Love it.
All right, Steve, thank you so much. It's been great to have you here. Be great if you can answer some of the questions in the background, and we'll move on to our last session. So thank you.
Cool.